Ever wondered how AI could generate a video that perfectly mirrors a specific person's face, like a friend delivering a speech, with their exact smile, facial structure, and every nuance preserved? It sounds like magic, but it's actually a complex challenge in AI known as identity-preserving video generation. Today, we're diving into a breakthrough solution called stand-in, which is redefining what's possible in this space. The problem: traditional AI approaches hit a wall. They either require massive datasets and computational power or produce videos where the subject's identity degrades. Think of a portrait where the face blurs into an unrecognizable blob, or worse, transforms into someone else entirely. It's like trying to paint with a brush that constantly loses its bristles. The AI can't lock onto the core features, and the result is a video that's technically impressive but emotionally hollow. Enter stand-in. This method doesn't build from scratch, it reuses existing AI infrastructure. Imagine a toolbox where you grab a pre-trained video generator, a model already skilled at creating videos, and attach a lightweight assistant to enforce identity consistency. This assistant uses a technique called restricted self-attention, which acts like a neural filter. It directs the model to focus solely on the reference face's critical features, like the distance between eyes, jawline contours, or even skin texture, while ignoring distractions like lighting, background noise, or camera angles. It's not just about matching a face, it's about encoding the essence of that identity into every frame. Here's how it works. You provide a single reference image, a photo of the subject. The system maps this image into the same latent space as the video generator, essentially translating the static face into a language the AI understands. As the video is generated frame by frame, the assistant continuously cross-references each frame with the original, adjusting for motion, expression, and perspective. And here's the kicker. It only needs around 2,000 training examples to master this, compared to the thousands or millions required by other methods. It's like teaching a dog to fetch by showing it a few balls instead of hundreds, efficient, precise, and scalable. The performance: stand-in outperforms competitors in two key metrics: face similarity, how closely the generated video matches the reference, and naturalness, how realistic the motion and expressions feel. On standard benchmarks, it achieves a face similarity score of 0.724, significantly higher than alternatives. Its lightweight design also means fewer parameters. Think of this as a streamlined engine and faster inference, making it practical for real-world applications like face swaps, animation pipelines, or even virtual avatars. But stand-in's versatility goes beyond humans. It works seamlessly with cartoon characters, animals, or even inanimate objects like a teddy bear. No additional training required. Picture a filmmaker preserving an actor's unique microexpressions across multiple scenes, or an artist turning a sketch into a dynamic, identity-consistent animation. The underlying models adapt effortlessly, treating any subject as a stand-in for the identity they represent. This isn't just about better videos, it's about AI that respects and preserves the essence of what you want to create. Stand-in bridges the gap between technical capability and creative intent, opening doors to applications we're only beginning to imagine. Whether you're a researcher, developer, or curious viewer, this marks a pivotal step in making AI not just powerful but purposeful.